Okay, for this problem, it reads, if the tension in the gantry crane hoisting cable is 14 kilonewtons, determine the unit vector in the direction of t, and then use this unit vector to determine the scalar components of t. And then we're told that point B is located at the center of the container top. All right, so let's zoom in here a little bit. And we just want to write a unit vector. So we'll do this one by kind of just thinking about the displacement that a person would take in order to get from point A to point B. All right, so N equals. All right, we can think about that as being the vector AB divided by the length of line AB. So I really just want to examine the displacement that I take in going from point A to point B and then dividing it by the length of that segment. So that would equal, in the x direction, I have a movement. Let's make sure we understand the x direction. So x is this way. So to get from A to B, notice I've got a vertical line drop down that positions me in the xy plane. So I'm going to move forward by 9 meters first. That gets me to this lower corner. And then since this point is at the center of the top, I'm going to have to go over half of this 3 meter distance. So I'm going to go 9 plus 3 divided by 2 in the I direction. Okay, if we think about the y direction, notice that y is running along this direction in the plane. And if we look at where this point that's directly below A is located, that's out by 12 meters in the y direction. And the edge of the container crane is located out 16 meters. So as I go forward from A to B, I'm going to travel by this distance, which is 4 meters, and then I'll go half of that 8 meter distance since I have to get to the center of the container crane, top. So this is plus, we'll go 4 plus, and I'll show it as 8 over 2 in the j direction. Again, that 4 meter distance is really, could be thought of as that 16 minus 12, where this is the 16 and that's the 12. Okay. The last piece that I have to do is the k, and in the k direction, if we think about going from A to B, I can go all the way down by 20, but then I would go back up by a distance of 3. So this is going to be plus a minus 20 plus 3 in the k. And we can divide this by the square root of all the terms in the numerator squared. And then if we write our unit vector, what we would find is that we have n is equal to 0.488 in the I plus 0.372 in the j, and then minus 0.790 in the k. So that is my unit vector. All right, now we want to use the unit vector to get the scalar components. So we can think that Tx, the x component of t, would be equal to the magnitude of t multiplying the x component of the unit vector. So we're told that t is 14 kilonewtons. So this is 14, and then we want the x component, which is 0.488. And that would give us Tx equal to 6.83 kilonewtons. Similarly, Ty can be thought of as the magnitude of t times the y component of the unit vector. So that'd be 14 times this piece, 0.372. And so Ty is equal to 5.20 kilonewtons. And then last is the z component, Tz, and that would be the magnitude of t times the z component of the unit vector. Don't forget the negative sign. So that's 14 times negative 0.790, or Tz is minus 11.06 kilonewtons. And that's all we have to do for this problem. So we went at this unit vector in kind of a different approach. We could have written the coordinates for point A and the coordinates for point B, and then taken the coordinates for B and subtracted the coordinates for A and done it that way. But I wanted to think about it in terms of displacement. You know, how do I get to point B from point A? So we look at x displacement, y displacement, and then z displacement. And if you wanted to draw it, you know, your unit vector would be parallel to t in the same direction there, headed from point A to point B. All right, that is it for this problem.